hazards and a brief introduction about why we go for this parameter analysis. Okay. Today we will be discussing about the radiation hazards. So, what are the effects of electromagnetic radiation and the S parameter? The S parameter, not in detail, just an introduction kind of like why do we go for S parameter analysis for this microwave applications? Okay. Yeah, to begin with, yeah, this is this is just one of the example of electromagnetic radiation. Okay, so which is taken with respect to a commercial application. So this is basically the survey based upon the so this is based upon the survey made in India, that is electromagnetic radiations which are the different source only at the particular zone. Preferably this is the data from the Delhi, what it has been taken, the numbers, all those things. Okay. Uh, so most of the data are from the Delhi region in this. Okay. So first on the left you see the RF sources in our country. Okay. So there are various RF sources and different numbers each again. See, there are FM towers. Yeah, I was mentioning this RF source in India. So one of it is the FM tower, which works at a range of 88 to 108 megahertz. Okay, and the power transmission of this tower is almost like 10 kilowatts of power. Okay, so most of the power which is transmitted will be transmitted through the air medium itself only. So as a total, there are 503 towers all over India. Yes, anyone asking anything? Chetan? Well, I hope everyone, I am audible to everyone. No disturbance at the background. It's coming back. So, FM tower, TV towers, 180 to 220 megahertz with a power transmission of a range of 40,000 watts. AM towers, 530 to 1620 kilohertz, power transmission of 100 kilowatts. Wi-Fi, 2.4 to 2.5 gigahertz, power transmission from 10 to 1000 milliwatts. Okay, and cell phone, it has a wide range of operation from 800 to 2.3 gigahertz. Okay, zero point 0.8 to 2.3 gigahertz with a power transmission of 20 watt with a total of six plus LANs towers around the India. Okay, mobile phones. Uh, your mobile phones operating frequencies. So GSM, which transmit over 2 watts. GSM, um, 1.8 to 1.8 gigahertz 3G, particularly what is mentioned here. Okay, and almost around 100 plus crore subscribers. That means those many number of users across the country. Okay, there will also be many towers across the uh, country again. Okay, so to again brief it, what happens in here? Usually the power what is needed for a single cell phone is of 1 watt actually. So here it is mentioned as 2 watt because when you make a call, the call will first go from your mobile phone to base tower. Okay, so 1 watt plus 20 watt. Okay, and from this base station it may reach to the destination, or from here this base station it will go to the another base station, so plus 20 watt. So from the other base station it will go to the destination or the receiver cell phone. Okay, so another 1 watt. So a total of 42 watt will be uh, used for communication from one mobile phone to another mobile phone. Okay, but again, in general, the power used by the device or as a whole will be of very less. It will be less than 1%. In fact, less than 1%. Not that. So what you need to observe here is, so 99%, that is if it is the overall transmission in the receiver, it is with the cell phone, if it is around 1 watt, less than 1 watt or 1% or so. Okay, that means among this 42 watt what I mentioned. Okay, 42 watt what I mentioned from source to destination with the two base station. um, 0.001% of the power will be used by your cell phone. Okay, and the remaining 41.99% will be used for, it will be dissipated. Okay, so it will be left over with the over the free space. So this is what you need to observe what happens with the what happens with these radiations when it is exposed, the exposed with these radiations, exposed with any other living beings, what happens to them. That is what we're going to discuss here. So this is another example. We have noticed that there will be a certain amount of warm sensation when we use the cell phone for a very long time. Okay, so here the temperature of earlobes increased by 1 degree centigrade when cell phone is used for a continuous 20 minutes. Okay, so warm sensation to pain, and it's an irreversible hearing loss and the ear tumor. So these are some of the hazards which occurs due to the continuous use of these EM radiations also. Okay, and to come over here to continue the same, the what are the hazards of electromagnetic radiation? This is just a continuation of these two examples what I have mentioned. Okay, So overexposure to certain types of electromagnetic radiations can be harmful. The higher the frequency of the radiation, the more damage it is likely to cause to the body. Okay. So microwave causes internal heating of body tissue. Okay. So if I take this as an example, with respect to the band, right? So if I take an example of this microwave oven which operates at a range of 2.4 gigahertz in fact. Okay, so say for example, what happens here? 2.4 gigahertz, which is an operating frequency of a microwave oven. So when you keep something inside the oven, what happens? It will heat, obviously. But how this procedure takes place? How the heating will occur inside the oven? Okay, so that is what you need to understand here. So say for example, you have kept some water for heating purpose inside the oven. So what happens with this water when you kept inside the oven means, so there is a water molecules obviously. What happens to these water molecules means, so microwave oven which is operating at 2.4 gigahertz, so these molecules will start vibrate at a speed of uh, 2.4 gigahertz, that is 2.4 billion times per second, right? So it will vibrate at a rate of 2.4 billion per second, which is nothing but your 2.4 gigahertz, the meaning. Okay, so when such vibrations occurs, if such uh, vibrations occurs, what happens to these water molecules? There will be a frictions which is created. Okay, friction which is created, and because of the friction, what happens? The heat is generated, and water starts heating. Right? Water start heating. Similarly, if you take an example of the same, this is due to the microwave, which is not good for the health. What I was actually mentioning here. Uh, if you take an example of the sunlight, so what happens? Just a minute, just a minute. Finish. Just a minute, I have a call. I will get back in another 2 minutes. ಮೇಡಮ್ ಇವ್ರು ಬಂದ್ರು ಅವರು ಸ್ಯಾನಿಟೈಸೇಷನ್ ಮಾಡೋರು ಮೇಲ್ ಬರ್ತಾ ಇದ್ದಾರೆ ಅದು ಲ್ಯಾಬ್ ಎರಡು ಸ್ಯಾನಿಟೈಸೇಷನ್ ಮಾಡಿಸಿ ಆಮೇಲೆ ಇವ್ರದ್ದು ಯಶವಂತ್ ಅವ್ರ ರೂಮ್ ಅದೆಲ್ಲ ಸ್ಯಾನಿಟೈಸೇಷನ್ ಮಾಡಿಸಿದ್ದಾರೆ ನಾಳೆ ಎಕ್ಸಾಮ್ ಇದೆಲ್ಲ ಅದೇ ನಾಳೆ ಎಕ್ಸಾಮ್ ಬೆಳಗ್ಗೆ ಅಷ್ಟೊತ್ತಿಗೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ ಇದನ್ನ ಮಾಡಿ ಸ್ಯಾನಿಟೈಸ್ ಮಾಡಿಸಿ Yes, sorry for the disturbance. Am I audible? Are you there? Yes, no, maybe.
Okay.
Okay. Yeah. What I was telling, I was explaining about the microwave oven, the phenomenon of the microwave oven. So this is a certain amount of heat. A certain amount of heat which is generated, which is used in terms of power. Okay, so if you are using more energy, the power and energy, how this power and energy are related? Energy is nothing but Power delay product. Power into time means what is the amount of energy you are getting means the amount of power that you are drawing from a particular source for what duration. Okay, so that is nothing but your energy, the amount of energy. So what I was actually mentioning here is so the power that is dissipated by the microwave oven is less compared to the power that we are getting from the direct sunlight. Okay, so this is the point you need to observe here. So even though the power is large from the direct sunlight, it is not harmful. Even though the power is less from the microwave oven or any microwave circuits, it is very much harmful to us. That's because so when you get power from the sunlight, what happens when you get the power from the sunlight? The sunlight heat will directly fall on our skin. Okay, so when it falls on our skin, the skin starts heating up. Okay, once that the upper layer is heated completely, only then the heat will transfuse to the lower layer. Okay, that is how the heat is transferred inside the body through the sunlight. Okay, and when it reaches inside, you will be getting sweating and all those things. Okay, so but in the case of microwave, what happens? So the microwave frequency, which is in terms of gigahertz, what I was mentioning. So this frequency can easily penetrate through your skin. Understood the point? So whereas the sunlight, which is very less frequency, means the time in which it is giving the heat and so on. So it is very less, but the frequency, microwave frequency is very high, which it can penetrate directly inside your skin. So when it penetrates inside your skin, what happens? That wave will catch up with the blood droplets or the tissues directly. Okay, so and there inside that droplet or the tissue, what happens? It starts to vibrate. How much times? Vibrate at a rate of 2.4 gigahertz. 2.4 gigahertz. That means it is going to vibrate 2.4 billion times per second. So uh, it is going to generate the heat by means of friction of these vibrations inside the blood molecules or the tissue. Okay, and by doing this, what happens? It will be having a direct effect on your DNA and all those things. Okay, so these are the medical issues which are the problems which occurs in person. Okay, so not get deep into this. This is just for your information to know how the things will go worse because of these microwaves. Of course, it has a different mm, different perspective, like personal ordinance or in terms of fuel. Okay, I mean how this uh, microwave will affect the personal health, how this microwave will affect the fuel, and how this microwave will affect the any electric body or something like that in a different category. So again, the same infrared radiation is felt as heat and causes skin to burn. Okay. So these are because of the higher frequencies, which makes your the small molecules or the tissues to vibrate. In fact, okay. So when it is vibrating, obviously because of friction, heat is generated, and because of that friction, heat is generated, and it will burn the it will causes the heat. That's it. Okay. So X-ray, which is again at the higher frequencies, it damages the cell, causing mutation, which may lead to cancer, and cell may die off. That is why doctors and dentists stand behind protective screen when they take a lot of X-rays. So gamma rays also damages cells, causing mutations and cell death. Okay, the same thing. So the same, what I was mentioning here, radiation hazards can be broken down into three categories. So electromagnetic radiation to ordnance. Ordnance means the electronic devices particular, or it may be any explosives, the sensitive electronic devices or explosive kind of. And fuel, what happens when it is exposed to the fuel, and personal, what I was mentioning here. Okay. So here in terms of personal, what I have explained, microwave radiation is used for communication, radar, and even cooking. Long-term exposure to this type of radiation can cause cataract, blister on the skin, that is skin cancer, sterility, and the microwave auditory effect, which is loss in the hearing, okay, because of microwave pulses. So other than this, you may have headaches and dizziness, blood disorders, which I was mentioning, birth defects in pregnant women, central nervous system damage, temporary sterility in men, cardiovascular problems, so increase in the stress. So these are some of the problems which occurs in personnel. Okay, so some biological effects cannot be explained by temperature rise in the body. Person working in a microwave field have reported headaches, eye strain, overall fatigue, and disturbance of sleep. These effects have been associated with the interaction of microwave fields with the central nervous system of the body. Such effects have been labeled as non-thermal interactions. Okay, so these may be responsible for some of the long-term effects from prolonged exposure to low level of electromagnetic fields. Okay, and next, due to ordinance. Okay, I'll just brief about it. Ordnance, what I was telling, hazardous of the electromagnetic radiations to ordnance. So it is also dangerous to ordnance like weapon system, safety and emergency devices and other equipments containing sensitive explosive devices. In addition to the attending personal and associated equipments, radiated fields can cause unintentional trigger of these electro-explosive devices. Okay. So as I told, these waves cause that molecules. It might be in terms of metals also or atoms. Okay, which tends to vibrate those atoms at a very high frequency, and because of that, heat is generated, or that might be trigger some of the electric appliances like that. Okay? And this ordinance is more sensitive than humans partially because they do not have circulatory systems to dissipate internal heat. Okay, that is because as a human body, it has a different ways of dissipating heat. But again, these explosives or any electronic devices, if they don't find any proper dissipation medium, uh, thermal agitation do occurs, and it will cause more effect than the personal. And this ordinance reacts to peak power, whereas humans reacts to average power over some time. Okay. So, however, these are more easily it can be protected by the effect of RF energy than humans by enclosing them with a metallic enclosure, because we as a humans cannot wrap ourselves with any metallic devices. Okay. Whereas in that you can do metallic protection, which will reflect back that incident microwave signals. Okay. And another, electromagnetic radiation in fuel. This is again the same. What happens in fuel? This occurs due to possibility of accidentally igniting fuel. Okay, as I told, the fuel liquid molecules get exposed to microwaves. It starts vibrating so many billion times, and obviously because of friction, heat is generated, and accidentally it may ignite the fuel vapors. Okay, and the same RF induced arcs during fuel handling operations in proximity to high level RF fields. So the probability of ignition may be significant for more than 50 volts amperes at arcs. So that is just a specification in general. So these are some of the hazards which you come across for uh, this effect due to electromagnetics. Okay. And the next topic what I was mentioning is yes parameter, right? Yes parameter. I'll just start this. So yes parameter. Before going to this, I hope you all are familiar about different parameter analysis done for the two-port network or any circuit so far in your earlier studies. Okay, like Z parameter, H parameter, Y parameter, ABCD parameters, like so on. Okay, here it is mentioned particularly S parameters. Again, here is a point to note that you cannot do any other type of parameter analysis. You cannot analyze it using this microwave circuit using any other type of parameter, which I told. Z parameter, Y parameter, ABCD parameters. You cannot use this, okay, for the microwave component. So why it is not used, or why only the S parameter is used in here is some of the reasons I will just list up. Here, mm, in this microwave circuits, what happens in the microwave circuits? So it's not possible to have open circuit and short circuit. Short circuit at this microwave frequency. So you don't have will be have any open circuit or short circuit in particular for this microwave component circuits. Okay, and the equipments are not readily available to measure the total current and voltage at these frequency. Okay, so that is uh, equipment. Equipment are not available, not readily available to measure total voltage and current like we used to do in the other network circuits at preferably low frequency. Okay, so to mention the same, we have certain formulas like KCL, KVL, like those things. If it is moving charges, current law, Ampere's law, Faraday's law, you may come across. But as I told, as the frequency increases, it is not only the voltage and current. Okay, the space will also come into the picture. I told. So it is not just V or I. It is actually V of t and V of I, and also V of x and I of x. Okay, the voltage or current at any particular location. Okay, and time as well. Okay, understood this point. So these are not available for the high frequencies for microwave components. And Another important is active devices. Active devices like tunnel diode, impact diode. So this we are going to discuss, and microwave transistors have transistors. These microwave transistors have a problem of stability. That is more important, particularly at microwave frequencies. Okay, so that is why we analyze it using S parameter. Okay, so here, as I told, to just brief it, I will not go it in detail. How will you measure this S parameter? S parameter, which is usually represented as Si comma J. So these two are subscript. Okay, Si comma J. So yes, I comma j means the first parameter I is basically the ith port, which will be particularly output port. J, the second parameter will be the j port, or particularly the input port. Okay, so yes, ij, how do we represent this? So this I will represent it as a ratio of normalized normalized reflected wave at I port in. So here it is the ratio actually. Normalized. This is input what I was telling. So it is incident wave at the airport. So here it is a division. Okay. So here. So this I is basically what it is. It is a reflected reflection at right out and what is it? J is actually incident at J point. Right. So this is how you define the this is how you define the S parameter. Again, if I consider, so for example, the reflection at B and the incident at A. Okay, so just I'm trying to define this in detail. Okay, so here B is the reflection at ith port and A is the incident at J port. Okay, basically it is a kind of power expression, the output by input. Okay, output is reflected and the input is basically incident. Okay, so for any particular ith what you call this bi is given as ratio of reflected voltage voltage at ith port, reflected voltage at ith port, and this is divided by Z. Characteristic impedance at this tube or the ith port. Similarly, AJ. Similarly, to define AJ, okay, the same way incident voltage at jth port. Divided by C. Okay. So this characteristic impedance of J it is. This is not I includes J. So this divided by this ratio will give you Sij. Right? So this is just a brief introduction about the S parameter. Why do we go across all these things? So we will not again go in detail like how do we calculate all these things and so on. Okay. So this completes the introduction about the S parameter. So next class we will just start with the microwave filters. So any doubt here? Any doubt for today's class? Record